many of the inferential statistical tests that are covered in a introduction to statistics course are used for analyzing scale data, numerical data, data that you can add, subtract, multiply, and divide with. But sometimes the data that we're working with is nominal ordinal. And what we're going to cover next, the chi-square goodness of fit test, is specifically designed to work with nominal data. Nominal data means that we have groups and they might have numerical numbers used, but they're categories. They're not numbers you would add or subtract, like numbers on a jersey. The numbers are used to make the data entry easy. So, for example, in SPSS where you see these 3 circles, that indicates that it's nominal data. And we're looking at, we can see here the labels, instrumental music and quiet. And rather than having to type in all of that, instrumental music might just be a 1 and quiet might just be a 2. And you'd record the data with the 1 or a 2. So the numbers are just names and they represent categories. So we'll take a look at how we would analyze data using the chi-square goodness of fit when we're working with one variable. And let's say that our assumption is that there should be an equal number of observations of all the different categories. Okay, to get started, we'll click on the Analyze drop-down menu. Then we're going to choose non-parametric tests. Parameter would be something like a mean or standard deviation. Those are parameters, population parameters. Chi-square is called a non-parametric test because there's no mean or standard deviation to work with. Numbers are just arbitrary names, so we wouldn't calculate their average or anything. So we'll click non-parametric tests. Then we're going into legacy dialogues. And here is, now careful how you pronounce this. This is chi-square. If you call it chi-square, people are going to know you didn't pay close attention. So it's a chi-square test. So click on that. And our dependent variable, and we're only going to have a dependent variable, is going to be assignment start strategy. So here we go. Click on it. And we move over to our test variable list. And then we click OK. So what SPS will do is it's going to show us the observation for each of these categories. So we have as a assignment start strategy to start early, 8 people chose that, or steady pacing, 15 people chose that, or get it all done in the last 24 hours, 13 people chose that. Now, for our chi-square goodness of fit, we went with the very simple null hypothesis that observations should be evenly dispersed among our categories. So we had 36 observations, 36 people participated, and if it truly was just spread across evenly, we would then expect 12 people in each of these conditions. Finally, our third column is called the residual, and it tells us how much of a difference was there between the observed and the expected. So residual of -4 means that we had 4 fewer observations than we expected. And the residual helps us see just how much variation was there between our null hypothesis, like in this case, observations would be evenly spread across. How much difference was there in that expectation? A -4, a 3, and a 1, that could be noteworthy. Okay, then we have our chi-square analysis. The chi-square value is 2.167. Degrees of freedom is 2. So degrees of freedom is not based upon our 36 participants. Degrees of freedom is based upon how many categories we had. And we had 3 categories. And the degrees of freedom is number of categories minus 1. So 3 minus 1 gets you 2 here. And then our p-value, listed here as asymmetrical significance, is 0.338. And that's bigger than our alpha level of 0.05. So we would retain the null hypothesis in this condition. All right, we'll go into game mode and see how well we can do this from memory, if you will. So we're going to do a chi-square. We're going to explore whether the spread of observations across our 3 categories for assignment start strategy. And those 3 categories were people who did it all in the last 24 hours, people who got an early start, and people who paced themselves evenly, right? So chi-square, our null hypothesis can be its observations are evenly divided among those conditions. So here we go, analyze. And then it's a non-parametric test. It's legacy dialogues. And here it is, chi-square. And we're going to pick our variable assignment start strategy. We'll move it over to the test variable list, and that's all we're doing. If, remember, all our categories we assume are equal, but we could specify different observation expectations, but we're going to stay with all equal. Click OK. Here's our residual differences, but not enough to be statistically significant since the p-value of 0.338 was bigger than our alpha level of 0.05.